Hi, everyone. Thanks for jumping in a little early. I will get us kicked off right at 11:30. All right, it's 11:30, so I will get us going. Thanks, everyone, for joining us here today for our webinar. My name is Gav Orman. I'm the Director of Compliance Technologies here with Toolkit. So today we're going to go over TRI data and the quality assurance, quality control process that goes into checking the extensive calculations that you do during TRI reporting season. We are recording this webinar, so it will be available after the fact as well. And if you have any questions, the Q&A is open and available to you. And I will also ask for questions at the end of the webinar. So like I said, my name is Gav Orman. I'm a registered environmental engineer, and I'm our Director of Compliance Technologies. Toolkit is a customizable active compliance management software suite, and we also do engage in traditional EHS compliance consulting. But what our focus is really to make day-to-day EH&S compliance both active and efficient. I'm sure everyone on this call is aware that we can get bogged down in a lot of those administrative data entry, permit tracking type tasks. And our goal is to kind of bridge the gap and make it so that you don't get stuck doing all of that administrative work and can instead use the information to improve your programs in an active way. The main tool that we offer that's relevant to today's discussion is going to be our TRI toolkit, which is an end-to-end EPA TRI reporting and submittal tool. It has built-in logic and utilizes IVAI, our AI agent, to reduce time, errors, and risk. It helps create defensible audit-ready records. So our system basically incorporates a lot of the QAQC tips and tricks we'll be talking about today already in the program. These are the other services we offer. I'm not going to go through each one so that we can get to the content for today, but in general, we have an environmental management system. We help with regulatory applicability determinations. We have a permit parsing system where you can upload your permit and it'll pull out all of your conditions and turn them into an actionable item, an actionable task that you can go complete. And we also have an emissions reporting tool, which is very similar to our TRI system. But today we're here to talk about quality assurance and quality control with our TRI data. We're going to start by just generally talking about QAQC processes and why it matters. Then we'll look at our threshold calculation portion of TRI and some spots where we can incorporate QAQC. We'll look at the release calculations and do the same thing. And then we will close by talking about the value of accurate TRI data and how this can help you at your company. So what is QAQCing and why does it matter? Quality assurance, the QA portion, is the proactive aspect of this. This is the standards that you set on how to process data. It's standards about data entry. It's the questions that you ask yourself as you get ready for TRI reporting. This is done throughout the life cycle and is often considered a preventative measure. So your standard operating procedures, that's a quality assurance measure. How you pull data from your SDSs or from your operations crew, that's a quality assurance component. Quality control, the QC side, is more of a reactive data control measure. This is where you're going to be measuring and validating that your final result meets the required standard, that your results are accurate. They're what you expected and they make sense. So quality assurance is kind of the pre-work that goes into making sure you're inputting good data, and quality control is what you're doing to make sure that you are calculating accurate data. So why is this important? I'm a big proponent of data is helpful and data is beneficial to us, but on a very practical standpoint, it's important to ensure that you have quality data for TRI because you're going to be submitting this directly to the EPA, and we want to make sure that data is accurate. If the EPA takes a notice of your facility and they dive into your data and they find some inconsistencies, it just brings a lot more eyes and a lot more visibility to what you are doing at your company. Accurate data and properly quality controlled data lowers overall company risk associated with the results of this information. When we're talking about TRI, we're talking about toxic chemical usage and toxic releases of those chemicals. And so it's important to make sure that this data is accurate and that you're not overestimating or underestimating to make sure that your company risk profile is accurate for insurance purposes, liabilities, and even, for the associated environmental permitting efforts that go into running an environmental program. It also makes your data usable for decision-making purposes and other reports. I've found through my years of consulting and working in environmental departments that TRI data is often very estimated or very stagnant. And so you do this huge effort to get your TRI report done each year, and then the data just sits there. I think TRI data can be used for a lot of planning purposes, sustainability efforts, and pollution prevention efforts. And so making sure that your TRI data is accurate makes it usable for business planning purposes, but it also makes it so that you can use it for other reports. There's a lot of overlap between TRI, air release reporting, and Tier 2 reporting. So to dive into the TRI threshold calculations, and we're going to talk about determining your threshold and what are common pitfalls and common areas that maybe we should focus on more for our quality assurance efforts, and then also ways that you can make quality control efforts on these calculations. So the big part of threshold calculations is going to be that SDS, product chemical information. Maybe you have a procurement system where your chemicals are speciated out, and so it's a little easier for you to pull that accurately because you just connect your systems together. Or maybe you are pulling up PDFs or paper files of SDSs and actually manually entering in your product chemicals information like that. And it's a lot of info, so it's easy to mess up. So some quality assurance measures are good to have, and one of those is making sure that all of your products that you use at your facility are represented. This can be hard if you have a really big facility where you have a lot of inputs and you have a lot of outputs, but identifying a way that you can make sure every chemical used on site is represented in your TRI is going to save you a lot of headache down the line. So what are ways we can do this? When we look at our end product, sometimes you just need to break it down by, okay, we have 5 products. Every single product, trace it back through your process to figure out what are your inputs. Make sure that you grab all the SDSs for those inputs and start creating your chemical inventory for TRI purposes. Now, if your facility is subject to Tier 2, you probably have a lot of this information already pulled, and so rely on that. If you have a Tier 2 chemical inventory, if you have an HMIS chemical inventory, you can cross-pull information. Just make sure that that information is coming from an accurate source. Did you double check the SDS and chemical speciation? It is incredibly easy to misalign percentages of chemicals in a product. So I've had a facility where they had two different solvents they were using. They had different percentages of isopropanol by like 0.05%. But that has a big impact if you're using it in the 200,000 gallon range. And so finding a way to confirm that your percentages are accurate is going to save you a lot of double work and rework. Ways that you can do that is getting a second pair of eyes on it or having some level of automation where you upload an SDS and it's automatically pulling out those values for you. The third thing here is, did you confirm that all of the TRI chemicals are accounted for? There are over 750 TRI chemicals on our TRI EPCRA list. And so that's a lot, especially in recent years when they're adding all of the new PFAS chemicals to this list. It is very important to check your chemical speciation and make sure that you are accounting for each TRI chemical that is in there. A second spot that's good to check over is going to be any test data that you're getting from assays or T-clips or blends. What units are your results in? You're going to see this as a trend throughout this webinar. It is the most common error in TRI reporting is going to be unit conversions. So if you have T-clip results and those are in milligrams per liter, are you properly converting that into whatever you need to get pounds at the end of the day? Or if you have milligrams per kilogram or ppm, or if you're talking about air and you're looking at MMSCF versus therms or BTUs, making sure that you don't make any assumptions, right? So just double check that your test data that you're using for your threshold evaluations, or even later, I'll bring up the release calculations. Make sure that you're checking those units and properly converting them. Do the CAS numbers align? TRI has a fun subset where you can have elemental metals, you can have metal compounds, you can have zinc fume and dust, you can have zinc metal. And so making sure that your CAS numbers align between your SDS, your TRI reporting, and eventually your Form R is really important to make sure that you're accounting for everything appropriately. And then usage amounts. What units are your entries in? It's really common for folks to track certain products and certain usages in tons, especially if you are a standard manufacturer or you're taking metal and you're just you're cutting it or manipulating it in some way. Maybe you're using 200,000 tons of steel each year, but eventually we need to get that into pounds. So just making sure that you have some level of flagging that tells you this is the units I'm in, this is where we need to go, and this is how we're going to get there. I use a lot of conditional formatting if I'm going to use a spreadsheet, where if it says tons, it's going to highlight it a certain color, and that tells me, hey, keep track of that. We need to convert it later. Same with gallons. I've seen facilities take gallons of paint and then just assume that's also what the pounds are, but you need that density calculation in there. And so have some level of flagging in your spreadsheets, whether that's conditional formatting or maybe you just take a bunch of notes in the spreadsheet itself. The more notes you take and the more information that you highlight, that's going to help you know what decisions you made while entering in your data. Quality control wise, your thresholds are calculated by multiplying how much of a product you used by the percent of that TRI chemical present in the product. Are your calculations running properly? My biggest pet peeve with a spreadsheet is if I enter in my usage data and then I go, oh shoot, I missed a product. And so I just go and enter in a row or a column to enter in that information. And now suddenly the whole spreadsheet's broken. But maybe you're referencing a cell and it still has a number. And so it's still going to give you an output. But that output might not be accurate anymore. And so being very careful about how you add in new information, but also what I like to do is have a space where I just double check. I say, hey, I used this many pounds of this product last year, and for some reason this year, I'm using triple that amount. Is that an error in my spreadsheet, or did we increase production? So having just quick little checks within your spreadsheet can really help you not have to dive into each individual Excel cell and rather give you a quick check of, okay, yeah, that makes sense. My data is in alignment with previous years. Which leads into, do the numbers make sense? If you're expecting 0.4 pounds of chromium and you're calculating 52 pounds of chromium, that's a big enough difference to make you go, that's odd. That doesn't quite make sense. Or if you're expecting 20,000 pounds and you're calculating 10 pounds, maybe you're missing a density somewhere, or you're missing a usage value. So it's always good to have a sense of what you reported previously or what you know. So if you submitted your air release inventory or air emission inventory, and you know what your throughput was of certain paints, and now it looks weird on your TRI calculations, that should be that trigger to you to dive in a little deeper and double check those values. The last one for thresholds that I find very valuable is to ask yourself, am I triggering the same thresholds as previous years? Am I triggering the thresholds that I expected to trigger? That's a really good sign that your threshold calculations are on track. Maybe you have minor errors in there, but you're not missing anything vital. All of the big things have been accounted for. If you've always reported for manganese compounds at your facility, and this year you're not triggering manganese compounds, that should prompt you to ask yourself, did we change products? Did we lower production significantly? Or is something wrong with my calculations? So that's really it for the threshold calculations. Thresholds, that first piece of TRI. And so once you finish your thresholds and you're good and you double checked your numbers, now you know what chemicals we need to figure out the releases for. So this next portion is going to talk about our release calculations and what we should do to confirm that those numbers are accurate. Release calculations can be complicated because it's very comprehensive. You're looking at fugitive air, point source air. You're looking at releases to water bodies from stormwater. You're looking at injection wells, if that's relevant to your facility, POTW and wastewater releases. We're looking at surface impoundments. We're looking at off-site transfers, any on-site treatment processes you might have. If you have any air pollution control equipment, that has its own releases associated with it and factors. So there's a lot of moving parts. The bonus to that is there's a lot of overlap. If you have an air permit, you've probably already calculated all of your air emissions and your air releases for the majority of these chemicals. Maybe you have one or two that aren't accounted for in there, but the vast majority of it should overlap with each other. Similarly for POTWs and wastewater, if you have wastewater leaving your site, you probably have the associated wastewater discharge permit. And so for that process, you take monthly samples and you can use that data to feed into your TRI calculations. The one thing that gets tricky about that is that you want to make sure that your TRI releases align with all of these other reports that you're submitting. A lot of facilities I've talked to assume that the EPA doesn't look that deeply at it, but they do. And so they will choose a selection of facilities and they will say, hey, you on your TRI, you said that you only emitted 20 pounds of copper, but in your air emission report, you said that you emitted 15,000 pounds of copper. Why are these different? So you need to have justifications for that. You need to have notes for that, and just make sure that you really know where all of your releases are. For the quality assurance component, we're going to be asking ourselves things like, are there any changes to your processes or release points that aren't accounted for in last year's spreadsheet? Is the spreadsheet or mechanism that you're using to calculate these releases fully up to date, or do I need to update it before I start entering in information? Like I said, how are you aligning your air releases with the air emission inventory? In terms of calculation functionality, what units are your results in? We report TRI in pounds, but the vast majority of our release profiles are going to be in milligrams per liter times gallons. Making sure that you get those unit conversions accurately keyed into your calculations is going to be really important. Are there any errors in your spreadsheet? I've seen spreadsheets where the errors are obvious, like there's a reference error or it's dividing by 0 for some reason. But I've also seen spreadsheets where it's still calculating and giving you a number. It's just missing something. So it's really important to take good notes and make sure that your spreadsheet's easy to follow. That way you have a visual trigger if there's an error in your calculations. And are the calculations referring to the correct cells? It is very easy to accidentally shift over calculations in a spreadsheet, especially if you're adding in or deleting any processes or release points. Quality control wise, I highly recommend having spots to validate your release calculations. So this can be a complete duplicate where you are redoing the entire calculation in a different cell and making sure that those numbers agree with each other, or it can be checking aspects of your calculation. So sometimes, depending on complexity, I'll actually have the whole calculation done in steps so that I can see each individual calculation being made. Other times, I'll just have a cell right next to it where it's calculating the exact same thing. And I have some conditional formatting where if they match, it turns green. And if they don't match, it turns red or orange or some other visual cue that something got messed up somewhere along the line. Again, ask yourself the question, do my results make sense? Does this align with previous year's TRI? Does this align with my other reporting requirements? Is this number way bigger or way smaller than I expected it to be? Those are the points where you should really dive in deeper and double check your math. Check your units and your unit conversions. It's really easy to add a 0. It's really easy to move a decimal point by accident. I just helped a facility where they were supposed to be dividing by 100 because it was a percent, but they divided by 1,000,000 because they thought it was ppm. And so it's really easy to make that error. It's easy to accidentally divide by 1,000 instead of 100. And so make sure that you are double checking all of those really tiny little entry points where your numbers maybe doesn't make a little sense. Are your unit conversions and any emission factors entered properly and accurately? Do you have like a stagnant area where you're saying, hey, this is what gallons to liters is, this is what inches to feet are, and it's easy to assume like, oh yeah, I know that I just divide inches by 12 to get feet. But even I've messed up where I am just like on autopilot entering in unit calculations. And so it's just always good to do that double check and make sure. And then calculation functionality, are they calculating correctly? Parentheses make a huge impact. Excel is going to read it and it's going to apply PEMDAS like we all learned in algebra. And if you're missing a parentheses, you might have 40,000 pounds released instead of 6,000 pounds released. And so the clearer and more accurate your equations are, the better you can be assured that your calculation is working properly. That's also why it's a good idea to have that duplicate area where you're double checking some of your calculations, where you're actually physically retyping in your equation. That way, if they are wildly different, you can start going, okay, did I miss a parentheses? Did I misplace a decimal point? All that good stuff. So Now that we have accurate data, we've done this whole process and it's taken us all year to get this report together. What is the value of accurate TRI data and how can we use it and so that it doesn't just sit in a spreadsheet? Accurate data is usable. TRI is a very comprehensive program. And so if it's done properly, there's a lot of overlap with other regulatory programs and a lot of other just business unit areas. Year-over-year comparisons of TRI chemical usage can show you where you might be able to optimize operations or have an increase in sustainability, depending on what your corporate priorities are and what you are trying to accomplish on site. So that year-over-year comparison, you can directly see these products are contributing to these releases. Is there a way that we can change these out, adapt, optimize our operations for this area so that we have less releases? Maybe you can trigger out of certain regulatory programs. Release data can also indicate where you might be able to reduce impacts or optimize specific processes to lower your overall facility risk factors. So if you have all these release points and the vast majority of your releases of toxic chemicals are coming from air or water or they're in hazardous waste, you can kind of focus your environmental initiatives on those specific areas to try and decrease risk at the facility. Accurate data is also more defensible. The more accurate and well-reviewed your data, the more confident that you can be in certifying it and standing behind it. If you have consistent, accurate data, it's going to increase the level of trust given to your facility by insurance brokers, by regulators, and by other companies, including your clients. So if you can stand there and say, I know that my data is accurate to the best of my knowledge and ability, you're going to have a lot more confidence in interfacing with your regulators and your clients. And that is all I have for you today. So this is my direct contact information. I highly recommend anyone on the call, go ahead and take a screenshot of that, write it down. I'm happy to help anyone with their TRI processes and any other EHS stuff you might need.